none other than the amazing Dr. Ben Santer tonight. We're so glad to have you here. We're going to get started in just 1 minute, but feel free in the chat to put your name and where you're calling in from. And we'd absolutely love to also steer people to start using the poll EV feature, which is live right now, and will allow you to start putting your questions for Dr. Santer in the order of being able to upvote them for the second half of our actual training tonight. So welcome everyone, and we are at time. So I'm just going to do a quick housekeeping slide and then pass it to Dana, our moderator tonight, to introduce our esteemed speaker. All right, so a quick reminder, all lines are muted. We are in meeting mode so that we can see each other, but just for the sake of efficiency, no one is able to unmute. At this point, the training is being recorded. It's going to be available in CCL Community as well as YouTube after tonight. If you have questions, please use poll EV, and we'll keep putting the link in the chat for you to use. We have an active activity already set up for you to upvote and type your own questions in. And in the meantime, you can use the chat specifically for the introductions and just interacting with each other. But we won't take questions from poll EV. Dr. Santer is going to have about a 20-minute presentation, and then the rest of the hour is Q&A. So I'm going to get out of the way and pass it to our moderator, the wonderful Dana Nucatelli, CCL's research coordinator, to introduce our esteemed speaker and then let him take it from there. Thank you all for joining us tonight, everyone.
All right, thanks, Brett. So Ben is a legend with a very extensive bio, so bear with me for a minute. Ben is an atmospheric scientist, was at Lawrence Livermore National Laboratory, although he just retired from there. He studies natural and human fingerprints in observed climate records, and his early research contributed to the historic 1995 conclusion of the IPCC reports that the balance of evidence suggests a discernible human influence on global climate. So he was the lead author of a key chapter of that report that drew that conclusion. And since then, since 1995, he's identified human fingerprints in atmospheric temperature and water vapor, ocean heat content, sea surface temperature, and hurricane formation regions, and many other climate variables. Ben's received a whole bunch of awards for his research, including a MacArthur Fellowship in 1998. He was joined the National Academy of Sciences in 2011 and got the Proctor Prize in 2019. He writes for the Scientific American blog and has appeared on Late Night with Seth Meyers, as I believe he's going to show us. And together with Chip Duncan and Dr. Hernando Garzon, Ben is a member of the Three Tenors of Climate Change, who are devoted to improving public understanding of science and impacts of human-caused climate change. And then Ben also just wrote kind of a retirement blog for my other home at Yale Climate Connections, so I'm going to put that into the chat. Everybody should read that. It's a really great piece, and he's also got some really nice accolades for us from some fellow top-tier climate scientists who had some very nice things to say about him. So, Ben, I'm going to hand it over to you, and the floor is yours.
Thank you very much, Dana. Thank you, Brett. What an honor to be here speaking to you tonight, ladies and gentlemen, just at the beginning of my retirement. So you have my very first talk post-retirement. And I want to give you a little sense of fingerprinting the climate system, something that's been very influential in terms of understanding the reality of human effects on climate, and something that last week actually led to the award of the Nobel Prize for Physics to Professor Klaus Hasselmann, the former head of the Max-Planck Institute for Meteorology in Hamburg. So I'm going to talk a little bit about how influential climate fingerprinting has been in the Intergovernmental Panel on Climate Change, and also how it contributed to Hasselmann's receipt of the 2021 Nobel Prize for Physics. So this isn't just a pretty picture here. This shows the amount of water vapor in Earth's atmosphere as measured from space on the day that Hurricane Katrina made landfall. And you can actually see, or actually this isn't the day Katrina made landfall. It's another day with all these magenta blobs here showing typhoons in the Western Pacific. And it illustrates that we can measure the total amount of water vapor in Earth's atmosphere and track its changes over time from space for about the last 30 years and see whether, due to human-caused warming of the atmosphere, water vapor is increasing. So I'll get back to that a little later in my talk. Before starting on the science component, I wanted to tell you a little bit about myself and about two events that shaped my life, two epiphanies. One took place here when I was 21 in the French Alps on this mountain here, the Aiguille d'Argentière near Chamonix. And I was climbing with a buddy doing the north face of the Aiguille d'Argentière and had the misfortune to fall in this glacier here. I fell about 150 feet into a crevasse. I saw a thin slit of blue sky above me, and I realized if I could climb out and reach that thin slit of blue sky, I would live. If not, I would not. So the calculus was pretty simple: get the heck out of that crevasse. And no matter how bad things have been in my professional career, I always remember what a joy it is to have gotten out of the crevasse and to be alive, to get up every morning and to continue to do my job and contribute a little bit in a small way to our understanding of this strange and beautiful world. So that was one big epiphany. And the other took place in this building here, the beautiful Palacio de Congresos de Madrid, in November 1995. What happened in this building? The Intergovernmental Panel on Climate Change met for 3 days, November 27th to 29th, to finalize the Working Group 1 assessment report of the IPCC. And it was at this meeting that these infamous 12 words were finalized. The balance of evidence suggests a discernible human influence on global climate. And that was really the first time that the international scientific community spoke with one voice and said, signal detection in our lifetime. We can formally identify a human-caused warming signal in surface temperature data. It was a big deal. I didn't realize it at the time, but this too would change my life just as much as falling in the crevasse and getting out of the crevasse had changed my life. So let's take a brief tour, if you will, through the six IPCC assessment reports that have been released. The first one was in 1990, and scientists back then concluded that the jury was out. We really couldn't tell whether humans were or were not affecting global climate. As I mentioned, the second assessment report came to a very different conclusion. Signal detection had been achieved. A human-caused warming signal was in data. That balance of evidence finding received a lot of criticism, and perhaps there will be some questions about that later. A lot of folks attacked the finding itself. A lot of folks didn't like me as convening lead author of the chapter in which that finding was situated. But 6 years later, in the third assessment report, a much stronger and more definitive conclusion was reached by the IPCC. They actually tried to quantify the size of the human effect on global climate and concluded famously that most of the warming observed over the second half of the 20th century was due to human activities. The fourth assessment report went one step further still in 2007 and used this likelihood language, that it was very likely that most of the warming since the mid-20th century was due to human-caused increases in greenhouse gases, where very likely meant greater than 90% likelihood that the statement was correct. The fifth assessment report in 2013 went one step further still and upped the likelihood language to extremely likely, greater than 95% probability that the statement was correct. And the most recent report, which came out just a few months ago, had this powerful word in it. It is unequivocal that human influence has warmed the atmosphere, the ocean, and the land. So why? How did we get from the jury is out in 1990 to unequivocal human influence on the climate system? And I'd like to just try and give you some sense of how I think that this progress was made. One is that we have better climate models. Back in the early 1990s, relatively primitive models of the ocean. Now we have full Earth system models, not only of the atmosphere, but full three-dimensional circulation of the ocean. They have embedded in them carbon cycles, models of the Greenland ice sheet, Antarctic ice sheets. These are fundamentally different beasts that enable scientists to get a much better understanding of the interrelationships between atmosphere, ocean, sea ice sheets, carbon cycle, ocean biogeochemistry. And that increase in the complexity and the sophistication of models has been to the benefit of the field. We have a better understanding of what you might call these interaction terms between different components of the climate system. And we have many more climate models too. Back in the late 80s and early 90s, we had arguably half a dozen climate models. Now we have many, many dozens from countries and institutes around the world. We have a better understanding of the factors that influence climate, human-caused changes in greenhouse gases, particulate pollution, changes to the land surface involving things like urbanization and deforestation, natural external factors like changes in the sun's energy output and volcanoes. We have a much better, deeper, and richer understanding now of those external drivers of climate. In 1990, satellite records of changes in temperature and water vapor were relatively short. For temperature, roughly 17 years. Now we have 42 years worth of satellite measurements of global scale changes in atmospheric temperature. Those improved and longer records have been extremely useful in helping us to better understand the causes of changes in our climate. We've also really moved from the analysis of climate simulations and climate data being in the purview of a small number of research institutes around the world to being a global activity where the analysis of climate simulations and satellite data has been crowdsourced. From the comfort of your own home, you can interrogate petabytes of simulation output and essentially look at all of the world's climate models. Why is that important? It's led to more eyeballs looking at the same climate data and ultimately led to better diagnosis of climate models and better understanding of what's going on in the real world climate system. And in order to enable that, we have platforms like this thing called the Earth System Grid Federation that enable scientists to share and move around very large volumes of data, visualization software. That too has been to the benefit of the entire field. Finally, we have climate fingerprinting, as I mentioned up front, powerful pattern recognition tools for trying to separate human and natural effects on climate. And that's what I'm going to talk about now, fingerprinting, very briefly. So what's the deal with fingerprinting? The basic idea is that different influences on climate, the sun, volcanoes, human-caused greenhouse gas increases, have different characteristic signatures. And those different patterns or fingerprints become manifest if you probe beyond one number, the global temperature of the planet, and look at complex patterns. And I'm going to give you an example here. These are different fingerprints. These are from climate models that have been run where you change only one thing at a time, according to our best understanding of how that factor actually changed. So each one of these fingerprints is a slice through the Earth's atmosphere, from the North Pole to the South Pole, and from the surface right up into the stratosphere, nearly 30 kilometers. And they're different. Yellow to red means warming, blue to purple means cooling. And without getting into the details of these things, the idea is that in climate model world, you can do these let's change only one thing at a time simulations. You can understand the unique fingerprints of the sun and greenhouse gases and sulfate pollution and volcanoes. And you can use this pattern information to disentangle these different influences in the observations. And the guy who really came up with this idea of fingerprinting was this gentleman here, Klaus Hasselmann. As I mentioned, one of the 3 co-recipients of the 2021 Nobel Prize in Physics. And Hasselmann's great insight in a paper published in 1979 was look at patterns. So up to that point, scientists trying to understand, say, surface temperature changes in response to increases in atmospheric CO2 looked at individual so-called grid points on the Earth's surface. And rather than looking at the big picture, taking a step back and looking at the entire pattern, they tried to figure out, well, at this point here or this point here, when I increase CO2, do I see a signal? So Hasselmann said, look at patterns, folks. And this is the kind of insight that enabled. This is from some of our subsequent work that we published a couple of years ago, that shows tropospheric temperature changes. And when you increase CO2, the entire lower atmosphere, the troposphere, warms. You get most warming in the northern hemisphere over the Arctic, less warming in the southern hemisphere. You get a bit more warming over land than over ocean. And all of this is sort of well understood. But the kicker is that this pattern in climate models of warming of the lower atmosphere as we increase CO2 is very different from this pattern here, which is the dominant pattern of natural fluctuations in climate associated with El Niños and La Niñas. This pattern, if you compare it with this guy here, shows areas where temperature increases and decreases simultaneously. It shows this sort of curious structure here in the Pacific. And it's obvious without doing any fancy statistics that the human fingerprint looks very different from the pattern of natural climate variability in troposphere temperature. So Hasselmann's insight was, we can use this kind of information to partition, to separate the fingerprint from the noise of natural climate variability, which is what many people around the world have done since this key insight in 1979. And I'll give you a quick example. So this is an estimate from the Berkeley Earth Group of one number, the average change in the surface temperature of the planet. And other groups, the Goddard Group under Jim Hansen, groups in the UK, groups in Asheville in North Carolina, have produced very similar estimates of global changes in land and ocean surface temperature. And we know from this kind of work that the temperature of the Earth has increased by about 1.3 degrees Celsius now relative to pre-industrial, so relative to the second half of the 19th century. And I guarantee you, you can look in your local paper and there are folks claiming even today that yes, this increase in the average temperature of Earth's surface is real, but it's due to the sun. It's purely natural and due to some uptick in the sun's energy output. So their argument would go like this. Over the last 140 years, they think there has been some small increase in the sun's energy output. If that were true, then one would expect more sunlight to arrive at the top of the Earth's atmosphere, and you'd expect to see heating throughout the full vertical extent of the atmosphere. Obviously, this is a sort of Homer Simpson view of the sun and the Earth, not drawn to scale, but that's the basic that's the basic assertion there from these solar enthusiasts, that a more active sun explains all of the global warming I just showed you. Well, does it? So we have these beautiful satellite temperature measurements, which is what you see here, of the microwave emissions from oxygen molecules. And those microwave fluxes depend on the temperature of different layers of the atmosphere. And by measuring at different microwave frequencies, using so-called microwave sounders on polar orbiting satellites, scientists have been able to look at the temperature, the vertical temperature structure of Earth's atmosphere and how it has changed since 1979, which is what you see here. And this too is a slice through the atmosphere from the South Pole to the North Pole, and from roughly 2 kilometers to about 20 kilometers. And the kicker is that the lower atmosphere has warmed, with most warming over the Arctic, where we've seen a very strong decrease, now over 45 to 50% in the coverage of Arctic sea ice. But the upper atmosphere, the stratosphere, has cooled, with the largest cooling over the Antarctic ozone hole. So this pattern of warming low down and cooling up high is fundamentally inconsistent with the notion that an uptick in the sun's energy output explains global warming. It can't. If the sun explains everything hypothesis were true, we would expect to see heating, so red colors throughout the full vertical extent of the atmosphere. That's not what we see in any of the satellite or weather balloon data. So the important thing I think about this vertical fingerprint and the power of looking at patterns is that this guy here, who was one of the other co-recipients of the 2021 Nobel Prize in Physics, Suki Manabe, predicted this vertical temperature fingerprint over 50 years ago in a paper published in early 1967 in the Journal of Atmospheric Sciences. So Suki Manabe was awarded the Nobel Prize for his work in climate modeling. He is literally one of the intellectual leaders of the enterprise of climate modeling. And back in '67, in a very simple model of Earth's atmosphere, he increased atmospheric CO2 from 150 to 300 to 600 parts per million. You're looking at a slice through the Earth's atmosphere again, but now just for global average temperature, from the surface right up to the stratosphere again. And what Manabe saw in this simple model was the upper atmosphere cools and the lower atmosphere warms. This was in 1967. Before we had the satellite data, it was a true prediction. And Suki Manabe could have been wrong, but as I showed you, he was not. When the satellite data came online, his prediction, you increase CO2, you trap heat more effectively lower in the atmosphere, the upper atmosphere cools, his prediction was right on the money. And that was powerful, showing the predictive skill of simple climate models. So the balance of evidence finding in 1995 was criticized. Most of the fingerprinting back then focused on surface temperature. And one of the lines of criticism was, you fingerprinters are just looking at temperature. If there really is a human-caused signal lurking in climate observations, you should see it in many attributes of the climate system, not just in temperature. So one of the things our group did in the 2000s is we looked beyond temperature. We looked at what I showed you in the very first image, satellite measurements of water vapor. And there too, we were able to show that as we burn fossil fuels and increase greenhouse gases and warm the Earth's oceans and lower atmosphere, we increase water vapor everywhere. That's why you see these blue to purple colors. But again, just like I showed you earlier for troposphere temperature, the dominant pattern of natural climate variability doesn't look like this water vapor increase everywhere fingerprint. It looks very different from it. But the satellite observations of water vapor change look much more like the human influence fingerprint than like natural climate variability. So the scientific community responded to that criticism. You need to look far beyond temperature by looking at water vapor, by looking at fingerprinting with clouds and rainfall and many, many different independently monitored attributes of the climate system. And that is what led the IPCC 2 months ago in its 6th assessment report to conclude that it is unequivocal that human fingerprints are on the climate system and that those fingerprints are pervasive. They're not limited to temperature or to the land or to the ocean or to the atmosphere. They're in pretty much everything we look at now. So fingerprinting has been powerful. Looking at multiple variables has been powerful. And I'm delighted that these two gentlemen who I've highlighted here today, Klaus Hasselmann and Suki Manabe, incredible scientists and incredible human beings, have been honored by receiving 2/3 of the 2021 Nobel Physics Prize. So just briefly here, I'm almost at the end. 2 lessons that I learned from having to defend the 1995 balance of evidence finding against significant, I would say, non-scientific criticism and attacks. One lesson is the importance of speaking science to power. So backing up a little bit here, in 2016, Senator Ted Cruz appeared on Late Night with Seth Meyer and launched his campaign for the Republican nomination for the presidency by making, on Seth Meyer, incorrect statements about satellite temperature data. Senator Cruz cherry-picked a small portion of the satellite temperature record that I showed you earlier and claimed incorrectly that this roughly 17, 18-year period showed no significant warming. My colleagues and I were asked to address Senator Cruz's claim, and we did, and we published a paper in early 2017 in the Journal of Climate showing that Senator Cruz was wrong, even if you cherry-picked, because of the background global warming trend in troposphere temperature. It didn't work. There was still a statistically significant warming trend in observed satellite temperature data. So that led to this opportunity to restore balance in the force in a Star Wars sense and go on Late Night with Seth Meyers for about 7.5 minutes of sheer terror and set the record straight. And I'm going to play you a little clip of my own experience of speaking science to power from February 2017, these 7.5 minutes on Late Night with Seth Meyers. And this is a clip right at the end.
You remain optimistic, and I was happy to hear that, but where are you finding optimism right now, considering the sort of deck that's stacked against you?
Well, it seems like a real teachable moment Climate science has been elevated in public discourse. Look at that. Look at Senator Cruz appearing on your program, making testable claims. The President of the United States saying nobody really knows the causes of climate change, and we do. So this is a moment when people are willing to listen, when I can come on your show and say, nobody really knows is wrong. It's fake news.
Yeah.
So what I want those teachable moments. I want to tell people, this is our understanding. These are the likely outcomes if we do nothing about the problem of human-caused climate change. And let's have a respectful, honest debate on what to do about it. But let's not dismiss this incorrectly as a hoax or a conspiracy. We all lose if we embrace ignorance with open arms.
Well, I couldn't agree with you more. And thank you so much for making the time. It's fantastic to have you here. Dr. Ben Santer, everybody. We'll be right back. That was great.
Like I said, 7.5 minutes of sheer terror. And if it takes a village to educate a student, it sure took a village and a lot of help from many people to prepare me for those 7.5 minutes, which I'd be happy to talk about later. Lesson 2 was declare your values. So let me declare, I'm not just a climate scientist, I'm also, as Dana mentioned, a climber. I've spent a lot of time since I was 18 climbing in beautiful, fragile, high alpine environments around the world. And what I'm going to show you now are pictures that I've taken during my 50 years as a climber in these beautiful environments. These places matter to me. And over one human lifetime, I've witnessed profound changes. Some of the glaciers I stood on with my dad as a little kid are almost gone. The notion that on our watch, these fundamental changes in Earth's climate system are occurring, and that our kids and grandkids, if we do nothing, will have a fundamentally different experience of these beautiful places in the world, coral reefs, rainforests, you name it. That's wrong. And in addition to the importance of a scientific discussion about the causes of climate change, we also need to have a discussion about values and what it means to lose these places, what it means if Earth changes in a bad way on our watch. So I always, at the end of presentations, tell people that we need to have not just a scientific discussion about the problem of human-caused climate change, but also a discussion about the kind of world in which we want to live and the kind of climate system we want to pass on to our descendants. So thanks very much for inviting me here today, and I'd be happy to answer any questions that you might have about the science or about the communication of the science, which has been a big interest of mine since the balance of evidence finding. I'm going to stop sharing now.
Yeah. All right, thanks, Ben. That was a really great presentation. So if you guys have questions or you want to vote up questions that will ask Dr. Santer, you can go to the link at the top of the screen there, pollev.com/CCL123. So I guess this is our first question. Is there anything you feel is missing from this report? I guess that's referring to the IPCC report. Anything that isn't included that you wish were?
Just to clarify here, are we referring to the 6th assessment report, the most recent one, or to the 2nd assessment report with the balance of evidence finding?
Let's say the most recent report.
You know, the most recent report, I think, has done the best job of all of the reports in terms of speaking in plain English and in terms of communicating about the reality and seriousness of climate change and the urgency with which we have to address it. But it's the physical science side of things. So the Working Group 2 report, which will be coming next, and the Working Group 3 report will deal respectively with the impacts of climate change on stuff we care about, agriculture, water resources, energy. And the Working Group 3 report will deal with mitigation and adaptation strategies for responding to climate change. So it's a little difficult at the moment to talk about things that are missing from this report. I'd like to see what the Working Group 2 and Working Group 3 reports have to say. There are always things missing. Reducing our understanding of the physical climate system and reducing tens of thousands of scientific papers to one volume is a tough job. You can never do justice to that. But from my perspective, it's not really what's missing that's important here. It's what's included that's important. And what's included is this one word, unequivocal, that we've come so far from the early days of this enterprise, from 90 and 95, from looking at a small number of aspects of climate change, primarily surface temperature, to being able to say now, everything we look at contains some imprint of climate change. And the most recent report focused particularly on regional manifestations of climate change and on extreme events. And more so than any other previous report, was able to synthesize and summarize science that showed humans are now changing the statistics, the duration, intensity, and frequency of many extreme events that are that really impact people. Think heat waves, think floods, the intensity of the most powerful hurricanes. That, I think, the inclusion of the regional aspects and the inclusion of the analysis of human contributions to changing extreme events, that is more salient than the stuff that is missing.
Yeah, that I particularly like the extreme weather attribution stuff. I've been putting a lot of that into my talks recently too, about heat waves becoming much more frequent than they used to, and droughts and floods and hurricanes and all those extreme weather events. Okay, next question. What's the effect of the NASA satellite measurements of 1 watt per square meter absorption due to changes in albedo and cloud cover? So that's the recent news that I guess we have some global dimming, essentially because of changes in cloud cover, making the Earth less reflective.
Right. And I believe some of that is change in surface albedo as well. It's not just cloud cover, but for example, the thing I mentioned earlier, the substantial decrease over the satellite era in Arctic sea ice extent. You have less white surface, you're exposing more darker underlying ocean surface. Snow cover, same deal in the Northern Hemisphere. We've observed decline in the areal extent of Northern Hemisphere snow cover. Greenland starting to melt around the edges of the ice sheet, expose darker underlying surfaces. So I think that the dimming is related both to surface albedo changes and to cloud cover changes, as I understand it. Mm-hmm. The surface albedo changes are deeply concerning because that's a positive feedback. When you expose these darker underlying ocean and land surfaces, you absorb more incoming sunlight, you warm ocean areas that were previously ice covered, you warm land areas that were previously snow covered, and that accelerates the melting of snow and sea ice, which is a bad thing. The cloud cover changes, I'm less sure I know how to interpret them. I think that one robust feature of the cloud cover changes is that as we've warmed the atmosphere, we've increased the height of clouds in many areas. We've changed the latitudinal location of clouds and storm tracks by expansion of the tropics. And in some cases, we've changed the optical properties of the clouds and the brightness of the clouds. I think the net effect of the cloud changes, according to both the fifth and the sixth assessment report of the IPCC, is that it's a positive feedback. So again, by changing cloud properties, the height of clouds, the optical brightness of clouds, the location of clouds, the net effect of all of those cloud changes is an amplifying positive feedback. So both of those things I've just mentioned, the surface albedo changes and the cloud changes, are not negative feedbacks. They're not things that are acting to slow down or diminish the warming caused by increasing atmospheric CO2. They're amplifying feedbacks, which is concerning.
Yeah, I mean, for a long time, one of the favorite hypotheses of a lot of climate contrarians was that clouds would be a big negative feedback on climate change, meaning it would dampen global warming because of changes in cloud cover that were at the time very uncertain. We didn't really know how they're going to change. And so like the Richard Linsons of the world would kind of pin all their hopes on clouds being a big negative feedback, and that, not too surprisingly, hasn't panned out.
No, that hasn't panned out. And I'm glad you mentioned that because it's illustrative of the way science works. People like Professor Linson have argued that there are these negative feedbacks that will save us all. And scientists have looked very, very carefully at the evidence for the existence of Linson's positive iris effect. They haven't ignored out of hand the Linson iris hypothesis. Folks have devoted years of their scientific career to sober, detailed analysis to see whether Linson was right or not. He was not right. And why is that important? Because, you know, many folks out there, unfortunately, who are skeptical of climate science say, well, climate scientists never look at alternate hypotheses. They dismiss them out of hand. Not true. I've spent a lot of my time looking, for example, at the hypothesis that the troposphere was cooling, a hypothesis that was around for much of my scientific career based on a flawed analysis of these satellite microwave sounder measurements. So that's the way science works. You confront these alternate hypotheses, you see whether they fit the bill. And unfortunately, in the case of Linson's iris hypothesis, the sun explains everything hypothesis, or the troposphere is cooling hypothesis, these hypotheses were shown to be wrong.
Yeah, exactly right. Okay, next question. Being a profound voice on how bad things can get in the coming years, what inspires you and gives you hope? Any recommendations or calls to action that we may take in fighting the good fight?
Well, let me take the what inspires you first. And there are a couple of different answers to that. One thing that inspires me is Citizens Climate Lobby. What an amazing organization. One of my friends, one of my very best friends, Peter Joseph, who is on this call today, and I'm going to embarrass him by saying this, but what the heck? I don't really care if I embarrass him. He's an amazing guy, an emergency room doc who, upon retirement, decided that he was going to devote his life and his passion and his energy and his intelligence, all of which are considerable, to a worthy problem, the problem of trying to make our planet's climate system more stable for his kids and grandkids, to devote his remaining years to Citizens Climate Lobby. And he has, and he's worked tirelessly for economic solutions. He continues to work tirelessly, and so many people in CCL have similarly given of their passion and time and money and energy to make this a better world. That inspires me. It really does. It's kind of what mathematicians call an existence principle, that good people exist who want to make this world a better place. So thank you, all of you, for what you do. Another thing that's inspirational to me is people like Greta Thunberg. Imagine going to the UN General Assembly and confronting world leaders, wagging your finger at them and saying, how dare you? How dare you jeopardize my future, my right to life, liberty, and the pursuit of happiness? That's been inspirational to me, to see young people flexing their muscles, recognizing that they have political power, that they can determine who represents them. To see that signal emerge from the noise has been inspirational for me. And finally, my colleagues inspire me. They go to work every day, irrespective of the administration that's in power, and they do everything they can to improve our understanding of this strange, beautiful, and complex climate system. They're the unsung heroes who make the measurements that are crucially important to understanding the size, rate, and significance of global climate change. There are the folks who spend their entire careers developing complex computer models of the climate system. There are the statisticians, the mathematicians, the computer programmers. So many people have given their lives to advancing understanding. And that too is inspirational to me. Recommendations or calls to action. Hey, keep on supporting Citizens Climate Lobby. Keep on trying to persuade our elected representatives that there are viable economic solutions out there, but that we need to implement them soon. And keep on using your voice, irrespective of how powerful the political forces seem that are allied with the forces of unreason. A few thoughts.
All right, thanks. And Peter Joseph says, "Aw shucks, Ben has been an inspiration to me, taking risks few would take on, integrity." So, feelings mutual. Okay, so what do you say when people speculate whether a specific extreme weather event is due to climate change?
Well, this whole field of looking at extreme weather events, at specific extreme weather events like the 2003 European summer heat wave, and trying to figure out the human contribution to the likelihood of that event and the severity of that event, is now pretty mature. So it started, like I said, really back in 2003 with the European summer heat wave, and people recognized that they could use climate models to simulate the world with us, the world with human intervention in the climate system, and the world with the world's weather with human-caused greenhouse gas changes. And they could also do the counterfactual, what a specific weather situation would have looked like without human-caused warming of the ocean surface and without human-caused changes in sea ice and snow cover. And now routinely, that's what folks in the World Weather Attribution Project do. They simulate the world with us, the world without us, and they look at how human-caused changes in climate altered the likelihood of specific extreme events. And in the case of heat waves, it's pretty clear, as the US National Academy of Sciences concluded in a report that was published 3 or 4 years ago, that the jury is in, and that human-caused warming of the surface and the lower atmosphere is changing the statistics of heat waves. It's making them more frequent, it's making them longer, and it's making them more intense. The scary thing was this summer, if you look at the Pacific Northwest, temperature records that were shattered in Portland, in Seattle, in British Columbia, the changes in those particular extreme events were so large that folks in my world are struggling to explain them just on the basis of global warming alone. It seems like changes in circulation also have to be invoked in order to understand the size of the changes in heat that we've seen recently, which is concerning, but makes sense as well. We know that, as you could see from one of my earlier slides, we're changing the large-scale temperature structure of the atmosphere by melting sea ice, by warming the Arctic preferentially relative to the tropics. We're changing temperature gradients between the tropics and the poles, which likely leads to changes in atmospheric circulation. And it's the combo of the background global warming by increasing greenhouse gases and the greenhouse gas induced changes in atmospheric circulation that is leading to these extraordinary record-shattering changes in heat that we are seeing, not just in the Pacific Northwest, but in Siberia, in Europe, in many places around the world. There's a lot we still need to understand in terms of those circulation changes. A lot of smart people are working on trying to understand that, but it's pretty clear that the jury is in terms of human-induced changes in extreme heat. It's also pretty clear that by moistening the atmosphere, and again, I showed you that increase in total amount of water vapor in the atmosphere, we are making extreme rainfall more extreme. So extreme storms have heavier rainfall. Hurricanes like Hurricane Harvey, which famously dumped over 50 inches of rainfall on Houston in a very short period of time, roughly 3 days. We're likely increasing the rainfall associated with storms like Harvey. So in answer to this question, the field of extreme event attribution is pretty mature now, and we can look both at categories of events, heat waves, extreme rainfall. We can look at specific extreme events, and using the machinery of event attribution, make some informed statements about how human activities, human-caused warming and moistening of the atmosphere and possibly circulation changes, have contributed to the changing likelihood of that category of events or of that specific event.
Yeah, interesting. Okay, I think we got time for one or two more. So let's see. What's the effect of the ocean current acceleration of 15% per decade by energy? So I think there was a study about a year or so ago that's basically found that ocean currents are moving faster than they used to. Do you have any insights about that?
Ocean, no, I don't. They're not talking about the thermohaline circulation in the North Atlantic, or are they?
I don't think so, because that one's slowing, and this was talking about a general acceleration of ocean currents.
General,
Yeah.
I would need to be familiar with the actual study in order to comment on it. You know,
Yeah.
what I have seen is what you've just mentioned, Dana. You know, there's some observational evidence and there's a lot of modeling evidence to suggest that if we continue to burn fossil fuels and warm the key regions of the North Atlantic that are really the driver regions for the North Atlantic conveyor belt circulation, then in model simulations and in some 50-year records of North Atlantic circulation, there's evidence of a slowdown of that circulation, which people have been concerned about because that circulation is responsible for transferring warmer, more saline water from the tropics via the Gulf Stream to the North Atlantic, which in part keeps temperatures in Northern Europe much warmer than they otherwise would be in the absence of that circulation. But I'm not familiar with the acceleration of other currents. I'm sorry.
Okay. Yeah, no problem. I wasn't really familiar with that research either. So Brett, can we pick a quick and simple one since we only got a couple minutes left? Let's see. How do you see science intersect with the role for ambitious policy asked for by climate advocates? Simple, right?
Well, my personal guiding principle has been to delimit the boundaries of my expertise. So I know something about the physical climate system. I know something about climate fingerprinting, statistical analysis of climate observations and climate simulations. And I've tried to confine most of my public speaking to that which I know best, to the science, to the fingerprinting. But it's pretty clear that that's not good enough anymore. Every public talk I give, people want to know, what can we do about it? Which is really in the purview of Citizens Climate Lobby. And in conversations with my friend Peter Joseph, I've realized that I need to inform myself better about different policy instruments for responding to the problem of human-caused climate change. It's just not good enough to say, hey, I'm a physical scientist. That's all I'm comfortable talking about. I can't answer your question. What should we do about it? In 2021, that's simply an inadequate response. So there is an intersection, I think, between the science that I've talked about tonight and the role for ambitious policy. And each of us, as scientists, has to spend some time examining, exploring, understanding that policy landscape so we can do a better job when asked, what should we do about it? We can do a better job answering that question. I've had many conversations with Peter about this. Fee and rebate seems to me, based on my imperfect understanding of policy instruments, to be the best and most effective solution out there. So I'm going to have to up my game a little bit, learn more about it, be educated by you, all of you, in order to be able to advocate for that when I interact with politicians, when I interact with the public. I hope that answers the question.
Yeah, I think that is a really good point to end on. So Brett, do you have some concluding remarks for us?
I think we
Oh,
can
there's a
squeeze in-
question, a real quick
I think we
question.
can squeeze in one more answer if you're
How
willing
to get out
to.
of the crafts?
So I use something called Prusik loops. Prusik loops are friction knots, and you have two of them. One of them is clipped to your harness, and one of them is clipped to a foot loop. And had I not known how to tie these Prusik knots, I would have been in trouble. There's some likelihood I would still be down there in that crevasse, and people would find me thousands of years from now and wonder, what the heck was this guy doing there? The beauty of Prusik loops is that if you know how to tie them, you shift them alternately. And when you put weight on them, they lock. The friction locks it onto the climbing rope. And when you remove your weight from them, you can slide them up. So you use these alternately. You stand up on the foot loop, shift that knot up, then you can slide up your loop to your waist harness, and it's a slow process of climbing a rope literally by friction. And I had practiced this during my time as a student at the University of East Anglia in the UK, a very flat part of the world. There were no cliffs around there to practice this kind of stuff, but there were disused railway bridges. So practicing Prusicking from a disused railway bridge somewhere outside of Norwich saved my life. I knew how to tie these things and how to use them then when I fell in this crevasse on the Aiguille d'Argentière.
That's a good story.
And a true one too.
Well, I don't want to interrupt any of your storytelling, Dr. Santer. This has just been a complete hour of just so much information and so much inspiration, and your gift to not only do the research, but translate it to all of us in the field, trying to best utilize it and really make those arguments in our own presentations and help others along the way is so invaluable. So a huge, huge round of applause from all of us on the line. And those that will be listening into this later, we are so honored for you to have shared your time tonight and help benefit all of us in that. For those that are on the line, if you're curious where you could find this after tonight, it will be on our YouTube channel, as well as the training event page where you found the RSVP information. We'll make sure to also put a PDF copy of Dr. Santer's amazing slides, so you can also find those for later use as well. And a quick shout out for those that are interested. We have an excellent climate science basics training that's featured here on the slide as well, for those that want to share that with the rest of their group on this intersection, since this is part of our core volunteer training series. Is there anything that we can close, Dana or Dr. Santer, that you wanted to end us with tonight?
I just wanted to thank you for organizing this event, and thank you really from the bottom of my heart for the good that you guys do in the world. I'm very, very grateful for your indefatigable efforts to convince policymakers to do the right thing and actually implement effective solutions to climate change. So thank you.
And thanks to you, Ben. That was thanks for spending an hour with us. That was really great and informative and entertaining. And congratulations on your retirement. I hope you enjoy it.
Well,
if you can call it that. What we're going to do, if you're all right with it, Ben, is we'll unmute all lines so everyone here, just for a quick little send off, can share their love here too as people sign off. So thank you all again for being on the line. Everyone is unmuted, and stay safe out there, everyone. Keep up the great work.
Thank you very much.
Thank you.
Thank you.
Happy retirement.
Yeah, thank
Thank
you.
you.
Excellent presentation.
take care, everyone. Thank you again for having me here tonight.
Thank you, Peter, for making it possible. Thank you, Ben, so much for joining.
Bye, folks. Good night.
Bye.
Be safe.
Thank you.